TruBits focuses on truOS, a convergent OS designed to solve complex business challenges. Beyond his entrepreneurial achievements, Rishraj Sir actively contributes to various organizations driving technological growth and innovation. Please join me in welcoming Rishraj Kaushik Sir. We look forward to his insights in what promises to be an inspiring session. Thank you.
Thank you very much for the nice introduction. So let us okay. So I would like to sit up. Oh, please not. I can continue with my voice until that's sorted out. So I would like this session to be a bit interactive. Like even during this talk of mine, I would like to engage with me, and if I may ask you questions also. Please be a part of that like conversation. Okay. I think I can continue. No problem. So today's topic is about future of Linux. So how many of you actually know something about, even if it's a name only, you know about Linux? Okay. Any more from that side? Okay. So that will be good. I can put it here and you can control from there. Next. So now the problem is that I have to go there to send the slides. Yeah, come in 2 minutes. Okay. So let me just carry the flow. So basically, we're now here to talk about Linux and like what it is, how it is, the concepts of Linux, and why it should be more used, especially by students, especially the students of your age who are the starting of their career, and they should learn about Linux and how they should move forward. So just. So I represent truBits. truBits is a company, it's a startup which deals in Linux-based technologies. We have like support for like from your standard desktops and laptops to cloud, to cloud as in servers, to embedded, to touch devices and all. This is like we'll talk about this a bit more. I represent here today talking about no that one. So that's my name. Like I have a W in front of me. It's not the W is silent. Okay. So this a little bit about myself. I have worked with some big names. I have also created some open source projects, and that like has full my like some of my credentials. Okay, I'll now talk about my a bit of my journey, how it all started. Okay, so it all started back in 2008. I was literally in actually high school, and okay. Okay. So in 2008, I was studying in Kendra Vidyalaya Maligaon, where I started. I was this person who was always tinkering with computers. My father was not happy because it means that some engineer has to come, like service engineers, to come and fix my computer because I was starting that time. So what happened is that during that time, I got very much interested in IT. There was no internet back then because where edge was like the starting. You will get a key in your phone whether it's phone network. It was good network when I was studying. So loading Wikipedia was like a minimum of a 1 minute job. That was the idea. So in that time, I was also experimenting a lot with whatever traditional, most popular OS people use even today, and that led to a situation that I generally get also lots sorts of things, so infections and all. So I started buying this commercial antivirus software. Thank you very much. So I started buying this commercial antivirus software, and my dad was like, "Okay, I cannot pay you more. Like, okay, it's like 1,200 rupees for a year is too much for me." Kind of that time. So during that time, so I thought like, okay, I need to somehow continue with my experiments, and somehow I need to learn. So in that time, I started like I used to buy all these magazines because internet was not a thing. So I used to buy these magazines where used to get some CDs of various like Linux and not even Linux of Unix distributions also. Distributions as in the operating system, individual operating systems. And these I used to like boot and test. And I realized one thing that they were very good technically, but the problem was that they were not friendly enough for people to like use it on day-to-day basis. So back then, since only desktops were like I had a desktop, didn't have a laptop. Desktop were the things, so I started. Okay, let's make a different distribution which can like be user friendly and all. So it started with the name SuperX. As you can see, I was a big fan of superheroes. Still, I am. And like all these Superman, Batman things were there. So I just named it SuperX. So that's what a 16-year-old old boy does. So that's the thing. And after, in 2024 itself, we came okay. It's too, like there were some reasons. So we'll discuss in private, but we decided to like move on and take truOS, which is the current uh, generation of operating systems we're doing. So with SuperX, we had around a lakh installations in Assam. So and like we had good amount of downloads every day. So that was a very like popular back then. We had very big universities using our systems, not only in their like academics, they're also using it for administration and like all sorts of departments, even general science departments. So that's like for example, the Cotton University is the oldest higher education institute in Northeast. They were also our users. And we briefly ranked number one in a website called DistroWatch, which this ranks the Linux OSs by popularity. We also became number one for a period of time. It's not safe. Now, I initially told about why I started. That was my personal thing. But why specifically start a Linux OS? Why not better start an antivirus company, which would have also solved my problem? I could have been much living a much happier life if I had started an antivirus company. It was much easier to do the sales and stuff. So one of the big things that I realized while I was like working on these things, the philosophical aspect of the entire Linux ecosystem. It's going too fast. Latency is high. Okay, so I realize that as an individual, I cannot do much. As an individual, I'm very much limited. But what empowers Linux and what empowers these hundreds and spin-offs of Linux, that is actually the community that is there. The community that why I am here talking to you guys, just to get you guys to join the community so that we together can build something much better rather than as an individual I will do something. So this is one of the reasons I started this Linux operating system company, and I would like to focus heavily on this aspect that a lot of people consider Linux to be freeware, not free software. So there is a very big differentiation between freeware and a free software. So anyone can tell the differentiation? Anyone willing to tell the differentiation? Okay. So basically freeware is a combination of the word free and where as in software, and it signifies that it's free of cost. So that's the word freeware. But when we talk about the word free software, it means freedom. It doesn't mean paisa. That's the major difference with free software and freeware. And I tried to give a translation. Okay, sure. Good timing. So I got my own system unactivated. So, anyways, so this is so here we have this Hindi word move. I can only the only common language here is move that I can say. So, so the Hindi word move is the very much similar to the word of free in free software. And open source, what is open source now? Again, so when you say free software, that is there. Now, what is open source? So imagine you are a company, or like when this free software company started, they're having a big challenge. How do you go to a Fortune 500 company CEO and tell them, I'm here to sell you free software? Nobody will buy if you go there up into a CEO's chamber and say that I am here to buy free software, sell you free software. They will not be bothered. So rather, the word open source was invented by the capitalist community, basically to sell free software. So open source is actually the technical aspects of free and open source software, FOSS in short. And while free is the philosophical aspect of FOSS. Both of them literally on practice mean the same thing. But in principles, they are very much different. While free software is all about giving individual freedom, the mukti to an individual. But in open source, it's all about business, and it is not bad, not a bad thing. We are not against business. Free software. One of the principles of free software is that if a software has to be free and truly free, it has to. The business aspect must be there. A person cannot live without earning something. So that business aspect must be there. So that's the whole concept of free and open source software. And the English phrase "free and freedom" was coined by the great Richard Stallman. Basically, just because the fact that English doesn't have a good word for freedom. Like free is the only word which is also signifying price and signifying your freedom. So that's why we have to write free as in freedom. Okay. So I request you guys to take a photograph of this if you would like to know about more. So these are certain freedoms that free software grants you. Okay, please take the photos. And there is a link below. That's GNU.org. If you go to GNU.org, you'll learn more about it. These are summarized versions because each sentence is of 3 lines. I would not have like too small fonts. It's better I kept a summary version here. So one of the biggest things about free software that enables you as a person is that you have the right to. Okay, I'd like to come up a bit about legal aspects of free software. So what is copyright? You know about copyright, right? So you get if you put my YouTube video, the YouTube that's being streamed right now, tomorrow in your private channel, the college may give you a copyright strike down, so it might be removed from your channel. So copyright actually enables an individual the power to decide the creative work, what you have done in your what you've done as a individual to be protected by law. So this allows you to make sure that nobody else can actually steal your work and say that it's my work. Now, what if you decide that okay, it's fine to take my work and call it a different name, as long as you make sure that you give me due credit. So that's the concept of copyleft. So copyleft is a direct opposite of copyright in the sense that you as a holder of the copyright, you are yourself saying that I do not I give you the permission to distribute my software or painting or music to the public, and you can make modifications to it. You can make enhancements and reduce or increase your features that or whatever you want to do, as long as you make sure that everybody else is also getting such freedom. You cannot deny them freedom. That is one reason why still today, if you go to, I think it's opensource.apple.com, I forgot. If you go to Apple's official open source webpage, to see that the source code of their kernels, which are the main component of the Mac OS, iOS systems, are already also available for public download, and you can actually build your own systems based on that. Because even Apple took open source components from the BSD project. BSD is another project. BSD stands for Berkeley Software Distribution, which comes from the University of California, Berkeley. So it's like, let's say it's a cousin of Linux. I'll not go into BSD now because that's another universe altogether. So I'll not go into that universe now. But just to give you an idea that every major tech company nowadays is using some form of open source project to develop their products, and that's how we have so many products in the market. If there was no concept of open source in the 80s, which it was developed, we wouldn't have seen your iPhones or your Macs, even Windows. I should name them because the entire networking stack of Windows is actually based on open source code written by somebody else. Now, in this, I would like to ask if you guys have any doubts on what I've just said. Okay. So in this thing of software licensing, we call it licensing. So if you search GitHub and go for any public repository, you will see a license file there or copying file. Either it's called copying or it's called license. It's a plain text file. Inside that text file, it lays down the groundwork on how to actually use that particular software. So that is our that's the law of that software. You have to follow by that law. Now, some of these licenses are called open source licenses are called strong copyleft licenses, and some of them are called weak copyleft licenses or weak free software licenses without copyleft. So what does it mean? Is basically developers around the world have decided they all have our personal preferences, right? I might want to make sure that my software, whoever else gets it, must also give it to others. That's my right to decide. And some people are okay if you just take my software and don't give it to others or don't share the source code, as long as you just give me a credit in the copyright header. Like you just write my name and we are fine with that. So there's a whole spectrum of like licenses. Starts from strong to weak. And some of are them we call them permissive licenses. Some of are so permissive that allows you to do whatever you want with that. It's like just not public domain. Now, public domain is something that you can take and do whatever you want. But just there is a license I cannot pronounce. I can say the name here because it's a bit of unparliamentary. But you can search about it. So this whatever you want to do license kind of a thing. This license allows you to do whatever the hell you want with that piece of creative material, be it software, be it your imaging and whatever you want to do. So that is the whole spectrum. Like you guys are getting bored, so I'm just asking you to interact with me. So it might be much helpful for me as well. Any doubts on that part? Okay, let's move forward now. Okay, and here I would also like to mention a bit about the KD community. I believe as students, this is the most important section of this entire presentation. If you want to like participate in some of the one of the biggest open source communities in the world, that would be KD. KD is so big, I would say, if you go back in and read some Iron Man comics that came in 2000s, you'd see inside the Iron Man helmet, there was no Jarvis, there was a KD desktop. And if you have seen you might have seen KD mentioned in even like a Netflix series like Mr. Robot and stuff. So it's a very, very big organization. And in fact, KD technologies are being heavily used to develop products that you might use every day. One such product is Chrome, Google Chrome. That how many of you guys use Google Chrome? Just hands up. Anybody not using Google Chrome? I'll also put my hands up. 3 people. What use? Okay. Okay. Safari is also a KD technology. I'll come to that. So yeah, I am also using this. So you might have seen the icon in the task bar during one was not full screen. Okay. Okay, it all started actually with Safari, didn't start with Google Chrome. So back in 2003-ish time, so Apple developers sent a mail to the KD mailing list. You know what is a mailing list, right? It's a group that when you send a mail to that email, everyone who is subscribed to that mailing list gets the email in their inbox. So it's like a primitive form of social media, I would say. Like everybody who's subscribing to some post will get that. So, so one of the core rendering engine of HTML web pages. You know what is the rendering engine? Okay. So HTML, you know HTML, right, you guys? HTML, you have to write all the syntax to like make a web page. Now, this syntax is what rendering engine converts it to a human readable format. The rendering engine is the key. Earlier, when I was working, there were so many rendering engines. Microsoft had its own rendering engine, Internet Explorer. Like Apple still has Safari and this WebKit rendering engine. Like Firefox still have its own rendering engine. So right now, only Firefox and Safari are like using something else. Everybody else is using this Chromium rendering engine, which is the basis of Chrome web browser. Also, Chromium is an open source project. So, 2020 in 2003, the mail came from Apple developers that they have forked KHTML into WebKit, and they are liking it a lot. So KHTML was a rendering engine developed by KE project, which was later forked by Apple. Forking is the process of creating a new derivative from an existing code base. So these are the words that I would like you to remember, because going forward as BCS students, you will be using these words a lot more than I'm talking right now. This will be a lot more. So what they did, they forked KHTML into WebKit, and that engine became the basis of Safari web browser. In around 2005 and 6, our Google guys also decided that okay, Safari is a very good browser, so we should make our own browser. And Google Chrome was released in the market, and Google Chrome was also using your WebKit at this time. So WebKit became the basis of a lot more things than it was originally developed. It was originally developed by maybe a few folks in the KDE community. The word community is very important because nobody was getting paid to write KHTML. Everybody were doing, students like you were doing in their free spare time. Right now, there are a lot of opportunities. Discuss that. Some of your in Germany, you can travel across Europe to present your projects in front of the global community. These opportunities are right now available. Back in 2003, maybe it was only passion that carried forward, this development. So in around 2008-ish, I believe, I don't remember the exact date, but I know when Chrome was released, I was one of the first users. That I know, but I don't exactly remember the date. So Google Chrome was released with WebKit. Now, what happened is that they further going like forward in around 2012 or 11, they decided that we'll again fork it, not make continuously based on what Apple is doing. We'll make something else. So that became the basis of the Blink engine, which is powering your web browsers, including the Operas, including Brave, including current generation of Microsoft browser called Edge, is also based on the Blink rendering engine, and the V8 JavaScript engine. So, and that again became something else. I'm just telling you how powerful the open source software is. That part of that JavaScript engine became Node.js. So it all started from one browser engine to another browser engine, then became something else. And now it's entirely a server-side computing platform called Node.js. And on the desktop, you have Electron, which is again based on Chromium. Chromium is the umbrella project for all this Blink and stuff. So we continue to use the word Chromium. Chromium is the father or the version of Chrome that is not yet branded. So when you use Google Chrome, it's just a branded version of it. So the Chromium project for multiple things like Node.js, Electron. I just don't want to list all the JavaScript libraries. I have 1 hour before mentioning JavaScript libraries only. So that's how and that's how you this particular thing. And it's not only there are other communities. Since I am like a member of the KDE, which is the foundation that governs the KDE project, not like as a corporate governance, it just represents us legally. Do something, we want to do something, you're entirely free to do it. And once in a year, you get to go to Europe and present your things what you have done in front of the global audience. Okay, any questions? I think you are saving all your questions for that, and that's actually a good thing. Yeah, you want to ask something? Okay, all right, all right. Okay, this is the final part. Means like not the final slide. This is the part where at least I will be now discussing about our products. So this is as you can see there is a laptop and the image that's too much in the background. One of the reasons now I was talking about reasons all along, but again I have to come to very specific reasons why develop your own Linux OS or distribution. So one of the things with Linux that I faced was majorly can be divided into two categories. One, how many of you have heard of the name of name called Puppy Linux? If it's still active, I suggest you download it and you know what I'm telling you. Like it is, it's a very good OS maybe for the audience it was developed for, but at least for me in 2008 studying in high school, it was kind of too much technical, and that was one of the intro operating systems that I had. So it was immediately a bouncer. I was immediately in back. So this is the first reason that I thought, okay, I need to fix this problem. I need to fix this unintuitive UI that's happening. And secondly, games, applications. You will not you will not know how much sacrifices you used to do as in the 2000s to actually try something other than Windows. It was very much of a sacrifice. You are like given the 10 things that you cannot do. And those 10 things are very, very important. One of them was playing games. 14-year-old boy is not playing games. So that's a very, very like thing that we will not expect 14-year-old to do. And also devices. Whenever you're buying, okay, I remember one instance when I was there was a time when Tata Photon was a thing. Have you heard the name Tata Photon? Have you seen the device? It's a USB dongle, and Tata Photon was very popular because it came in the CDMA, I think, the CDMA device, which was giving good speeds. I mean, how much good speeds? Get around 250 kbps download speeds, which was a big speed bump compared to 20 kbps in addition. So this Tata Photon device, and there was something equivalent released by Airtel also. So I went to a Airtel store, I remember that, or a Tata store for one, and asked them for this their latest device, and along with the hardware. And they said it was the Windows Vista era. So they were like it was written support Windows XP, Windows Vista. Vista was the latest hot thing there. I asked the question that you might have never heard. Does it work in Linux? Like they were like shocked, like and one fine lady came and said, no, it doesn't work in Linux. It's a purely updated device. They're not even claiming, telling the fact that they don't make the drivers or their OEM, whoever made this device, is not providing the driver. But they're saying that you have to update your OS, kind of thing. So that was the scenario with devices that I was facing. Every printer you buy, you have to be very, very careful, like whether that is in the supported list. And there was not a good list of people. Okay, these 10 devices are supported. Okay, it was like read through source code to find whether these devices are supported. Class of devices. So that was a big problem that pushed me to really come forward and develop my own. Okay, now let's talk about the future and present. So what it is, so after all these stories that I've told you, I came to realization it's now time to make my own thing. And even after like this year only, right, starting of this year, we released truOS, which we feel that is the most powerful variant of Linux we have. So truOS is basically one single platform where you can develop your applications and make sure that it runs across multiple form factors. Form factors I just turned it off. Yeah. So, all right. So, coming back to the topic in hand. So, truOS is basically a single platform that you are seeing some of the devices here. It is very hard to put a Raspberry Pi somewhere in this big image, so that's not there. But the main point is that we are supporting like a variety of form factors. Be it your traditional desktops that I'm presenting from is a truOS laptop, for instance, and two phones. And in fact, I was supposed to bring one touch device today, but like I forgot about it. So sorry for that. We might have some another day to demonstrate some touch devices also. So, and we have support for cloud. So in cloud computing, you name like basically you can run as a server OS and host your applications there. You can host your websites there and all those things. Finally, for your IoT projects. So as BCS students going forward, you will have IoT needs. So now the problem with IoT is that you do not you need a very specialized operating system for the, the low resource environment in this small devices. Now generally the what is available in the market are like a pharmacy. Like you go to a pharmacy and you give you the tablets for fever, they take it, but it might be different fever. So truOS on the other hand is like a doctor. If you take your IoT project and you want a specific thing to be done, because in general you are not doing general purpose computing in small embedded devices. You're doing special purpose computing. For the special purpose computing, our truOS, we have custom variants for everything, so when you can do special purpose things. From like I would like to mention, like for instance, like controlling all these lights and all, it can also tell you when it's going to be flood in Bangalore, all these kind of things. At least in your area, you can also determine how fertile is your land. All these applications are there with IoT. So all these areas we can use truOS also. Apart from that, any application that you may write on the laptop for truOS is automatically portable to the touch devices, phone devices, if it has a user interface. And the for the rest of it, the backend is there. So we write generally write in two things. One is the front end. We write in Kirigami. Kirigami is a superset of Qt. Actually, it's a superset of QML, specifically Qt markup language, and that is it's very similar to like it has concepts of HTML. It has and it is like the writing style is like JavaScript. It's very easy to learn. If I can, I'll try to show you some of the applications that we have developed. Especially, I might be able to show you the store, app store, or something that we have in our truOS that you might learn, because that's one of my own early critical projects. So that is very crude. So I just use it for demonstration purposes, because I believe that that will be the state you will be in right now if you start doing. Okay, and the backend we write in Python. So, or we can use C++. Most of the like, since again I'm mentioning KDE here, most of the KDE is written in C++, and the Qt is written in C++. So, but it does have bindings. Bindings are basically some files that you get are generated for language interoperability. So you can, like, Python can talk to the C++ backend directly. But as a developer, you will not need to take the overhead of Python. It's raw power is there, but it's also very complicated language to use and develop applications. So we are promoting the Python thing, not the C++. Okay. Okay. Coming to some of the important features of truOS. So this is apply to multiple versions, but since they appear first on the desktop version of truOS, I'm just mentioning the desktop here. But they are applicable to almost all variants of truOS. So first of all, I would say that truOS is very secure. Like somebody just came and I did not understand what he said, but I just got the word cyber security. Yes. So one of the biggest thing is that you get targeted as individuals. You get like targeted by companies as well as malicious actors. So this was one of the reasons I needed antivirus protection back when I was doing all these things. So with truOS, you already get the security of Linux, which comes by default. On top of that, truOS is an immutable system where the root partition, like the file system, the C drive of truOS, is basically read only. So you do not change its underlying architecture. It is always in factory state. So this results in not only you being secure because of better architecture of Linux, it also means that you can, a third party may not install anything on the system. Even if you somehow got the root privileges, you will not be able to install anything on the system. One of the other things is that I already mentioned focus on usability. As you can see in the screenshot, I'll show you a demo also. It is not bad, right? It doesn't look bad. You see, it's similar to your iPads and Android tablets in terms of UX. So we are very much focused on usability so that we can grow our community more. Now, two of these things are a bit of technical. I'll just try to explain it in simple terms. One is memory compression. So what happens is that in systems, especially in embedded or limited memory systems, say if you have a old PC like with the 2 GB RAM or something. Now, how does an OS works? An OS is basically trying to manage whatever you're doing in the system in real time. It is trying to manage your RAM. It is trying to manage your CPU, like how much processing time should be cycles, we call it cycles, CPU cycles, should be allocated to one particular process. If it gets too technical, please raise your hands. I will try to explain it one more time in a much like lesser technical maybe manner. So whenever the CPU is running, CPU has something called gigahertz, right? This is just a oscillator, to be honest. It's like a oscillator. It's not just a oscillator. It's like a oscillator. So it has limited gigahertz. So it has to manage when you are doing browsing a web page and suddenly you start playing a video on your say media player. I don't know whether people do it nowadays, but we used to do. So the moment a video is loaded, a movie is loaded in the system has to determine how much processing power is to be given and how much RAM to be given. The RAM is again a finite number. You have 2 GB of RAM. And suddenly you open a big application which is a very heavy video editing or photo editing software. Now it will take, or even a browser. Nowadays browsers take most of the RAM. You don't need a fancy software for that. So the taking example of Google Chrome only. So if you open Google Chrome on a limited memory system, what happens at that time? It starts paging. Paging is a process when the system is out of memory, but the memory is memory, right? Your hard drive is there, your SSD is there as a backup. It tries to send the unused things to your hard drive or SSD. If you have seen old computers with a spinning hard drive, if it gets handed some time to, like if you like switch application, it takes some time to get the response because of paging that's happening in the background. The unused parts of the software they're all files. They're sent to your hard drive for safekeeping when the execution, the runtime is happening, the execution of the program is happening. Now, instead of doing that, what is the alternate approach we can do? Alternate approach is obviously you can get an SSD, spend some money. You can nowadays every other machine is coming with SSD, but it's not always the fastest type of SSD. In that sense, also you need some form of memory compression. Memory compression does is that instead of sending the pages out of memory to your secondary storage device, what it does is that it tries to compress the unused pages within the memory itself. So, for example, it will give you a 40% boost. On average, it can be 20% also, but on average, it gets a 40% boost if you are on your application runtime capability. If you are using our system with memory compression, because that will compress the pages. And since CPU cycles, the CPU processing cycles are much faster than your SSD or your spinning hard drives, so that time of compressing and decompressing is much lesser. Yes, it does increase your CPU uses. That is a byproduct or a side effect, but that is acceptable if it's only happening for 2 or 3 seconds. Like your CPU may go 100% for 2 seconds when it's reading up old page and bringing back to memory, and it goes to normal. So that's how memory compression works. And we also have something called application preloading. They are actually enemies. Preloading and memory compression are enemies in a sense, but still we have finally tried to make them work together. So what does preloading do? So in your system, you have some common apps that you use. On your phone also, you might have, say, Instagram is very, nowadays the generation are using Instagram a lot. Or our generation used to do Facebook a lot. So like there's some applications that you are using all day. And these applications generally have something called shared libraries. It's a very simple term. Shared means shared. It's been shared between all the things. And the libraries are the files that are necessary. In Windows, you have DLL files, dynamic link libraries. So they are actually libraries which are giving applications some resource to work on something. So that is your what does preloading does in this scenario? Preload takes your user's behavior. It takes what you are actually doing with your system. Maybe in the first 2 or 3 runs, it tries what are the applications you are loading. Not only you are loading, by default, the operating system may start a lot of services. They're also loading a lot of libraries. The most common would be the C library, the standard C library, which is loaded by the kernel itself. So it's like very common. So, or other libraries, like in our system, the Qt, entire Qt library will be loaded. So in this scenario, what happens is that these libraries are cached beforehand. You start working on the machine. So the moment you start, they are loaded to the RAM, and that results in much faster response time from applications. Now again, coming to the fact that nowadays laptops or desktops are coming with SSDs which are very fast, but in today's world also, if you are on a budget, you take a laptop around 35-40K, it might not have the best SSD. It might show you it has an SSD. You might see the okay, it's not a Gen 4 NVMe SSD. It may look like it may not be, because the motherboards may not support. In those scenarios, especially memory compression, application preloading works very good, because it gives you the snappiness of the system. The snappiness is very good. Okay. Any questions on memory compression and preloading specifically? Anybody? Yes. Okay, that's a very good question. So I'll tell you how it is implemented. So that will actually answer that question. So how it is implemented is that instead of trying to do all these complex things that may arise, okay, what we do is that we create a separate virtual device in the OS, and that virtual device is residing in the RAM itself. So the kernel is not actually bothered whether it's a SSD or a hard drive or it's a virtual device. The RAM, the items are directly paged to the device. That device can be mounted as a file system in the system. In Windows, for instance, you used to have something called a pen drive memory boosting or something like that. In my days, in Vista era, I remember that you can insert a pen drive and it will give you a boost of memory. It's the same concept. We're not actually trying to go inside the kernel and tell it to compress. It is a separate block device, which like your pages are directly paged to that. So it's a swap. It's called swap in Linux. The swap space. It's a swap partition. But instead of a physical partition, it's a virtual partition in the RAM itself. So that makes it. That gives the benefit of RAM fast access, and it also reduces the things. In fact, this particular technology, being it open source, is now part of the Android ecosystem as well. So they are also doing the same with. If you are using Android, that's what Android is also doing. But it came much earlier in our systems rather than Android. Just to mention that. Did I answer your question? Or did I answer your question? Okay. So now again, let's talk about one more variant of truOS. We call it cloud, because it works on servers. Cloud is nothing but someone else's computer. So that's something you need to like I'm just always saying, whenever you say serverless, it's actually you are renting a server for some 10 seconds or so. So there is nothing called cloud, there is nothing called server, but we're calling our system truOS cloud because it acts very well on those environments that I just mentioned. So one of the basis of truOS is Debian. So you heard of Debian? Anybody who heard of Debian? I've talked about KDE. Now I'm also talking about the Debian project. Anybody? No. Okay. You've heard of the name Ubuntu for some reason? No Ubuntu users? Okay, maybe they will install these things coming in the upcoming semesters. So these are some of the popular names, much popular than truOS because we just started. So Debian is a very stable operating system. If you ask any system administrator, like what is your preference? Either it will be Red Hat or it will be Debian. Most of the time, some variant of Red Hat or Debian. So we are also basing on Debian's stability. So we are saying stability guarantee. We are basing on the Debian stable branch, which is actually much more stable than stable. Even their testing branch is a basis for Ubuntu. Ubuntu uses Debian as well, but they're using the testing branch, which is again very stable. It's like the naming conventions are like that. So we are doing that. Cloud, we are actually giving you like long-term support. If you are deploying our application for 5 years, you're guaranteed that in your that server will not gap because of lack of OS updates. Something recently happened in the enterprise space when a certain company stopped services all of a sudden, like that created a lot of havoc. But we are at least guaranteeing that. And management services. This is very important part of this technical part of this conversation. We are in truOS. We have something called True Hive, so which lets you, especially it will be very helpful for your IT team here, because if you have hundreds of machines, thousands of machines in a system, you may decide to restart them at once. Turning on may not be possible without wake up and land, but turning off is possible, restarting is possible, installing software is possible. All this that you might need one person to do it, and especially in computer labs. I have seen in many universities back home that when the lab is over, students are gone. It's the 4 p.m. time. Like the sysadmins generally like press the button, keep on pressing the button until it's forced shut down. So that results in a lot of hardware failures. It has resulted in a lot of hardware failure, hard disk failure, and all those things. So this in these scenarios, we have TruHive, which can be beneficial, and we can like manage all these hundreds and thousands of machines from a single control panel, which is again cloud based. So that's the management services part. If you want to go into detail how these conversations between these client systems and server system, my contact details will be available in the last slide. If you are interested, you can. Okay. Again, Nano. I have mentioned all this, but one of the things is that by default in truOS Nano, but making sure that the memory footprints are low, that you do not even need memory compression. If you have a project where you need to turn on a light bulb, you should only turn on a light bulb. You should not have the entire multimedia stack running in the background and promising you good features that suddenly this bulb will start singing. But the point is that it should only have those basic bare minimum things that it should have. So that is that is true as Nano with low memory. It doesn't include a lot of things. We do support a wide range of SOCs like system on chips. Like for example, one example is system on chip, where we can like even we support a Raspberry Pi Zero first generation, which is a 32-bit ARM CPU. Now, do you know about ARM and x86? Anybody? Okay, just giving you one, just taking. I'm doing some like asking this question as a skill. Like, to what extent I should explain? If I explain, keep on saying ARM, you do not understand. So that's a please, I can like take it a bit. So every CPU has its architecture. Whatever you are using right now is generally called x86 architecture. So these are complex instruction set computers. You will learn in your degrees during your degrees. So I'll not explain all those things. But the moot point is that there are a software developed for architecture A will not work in architecture. So to develop an OS for a different architecture is again you have to think a lot. The battery is running low in the system. So here what we do is x86 is your traditional desktops and laptops mostly, and also the traditional servers that are there in most of your laptops. Here we have another variant of CPU called ARM, which is like mostly used by in your Snapdragon, for instance. The M1 recently in Mac, M1, M2, M3, M4 are all ARM-based CPUs. ARM is not complicated in terms of design. It's very simple. But that also brings in the challenge that you have to be very specific about the chip. That's why the Android variants from OnePlus will not work in Samsung and vice versa, because they are specifically the hardware drivers and the configurations are made for that device. That's why you do not install Windows on a M1, M2, M3, M series MacBooks. But maybe earlier MacBooks with Intel chips, that is x86 chips, had something called Boot Camp, which allowed you to run Windows in Mac. But nowadays, Boot Camp is gone. There is no longer the support for Boot Camp, and it is M series only macOS compiled for that. In truOS Nano, we have support for some of the oldest architectures in available. That is ARM32. Why? The question is why? Why is this fellow always talking about old stuff? Like we are already progressing, this generation is progressing. Why this fellow is always talking about the old stuff? This is a very question that came to my mind just now. One of the reasons is that since we in India we are very much price cautious when it comes to technology. They make a film out of it, and we send people in space instead of filming, making a film and spend half or 1/10 of the budget. Was the Chandrayaan or Mangalyaan, which was like the 1/10 of the budget for gravity. Right? So we are very much price conscious society, and in that scenario, what happens when you're doing an IoT project? Will you spend 8,000 rupees for a high-end latest generation system on chip like Raspberry Pi, or will you spend say 750 rupees to get your project done? Which one you will choose? And that is one of the reasons we're still supporting one of the oldest architectures available. And finally, we have customization services that like where you can customize. We will customize the OS as per project. Okay, I'm just. We also have this. I've also already mentioned about truOS Mobile. truOS Mobile is a mobile OS. It runs Plasma Mobile, which is again a KDE project. And I'll go to KDE projects a bit. Are we out of time? We can. So okay. So with this, we are building some devices for rugged use. For instance, police, military, and all those people who need security. I've mentioned already, and their devices are rugged. So we are working with them to get these devices out. It has all the features mentioned in the desktop, all the compression and everything. Yeah, and we write. You can write convergent applications on desktop. No change in code. If it's Python, no recompiling to ARM also. Just bring the machine, bring the code from here to here. And yeah, if you have been ordering fast food in some restaurants, like these are one of the things that we can do. We can make terminals, like iOS terminals with touch. So Touch is a custom OS for custom kind of things. It will be branded for your needs. If you have a company or a business that wants that, this is for that. Okay. I've already talked about immutable systems, and this basically means I just would like to take a minute to explain that how it works. Is that you guys know what a multiverse? Like you've seen the Marvel movies where there are multiple variants of a thing, right? It's like works in the same concept. When you have an operating system running, that's your present universe that you are residing in. The moment you want to install software, since it's read only, it will not install. Either you have to install inside containers, which are microsystems inside the system only, or what you can do is to install in the system maybe some updates that we have released. They are installed in a parallel universe, which is created at the moment it like you start the installation process. This parallel universe is where all the changes happen. Now, to make sure that these changes are accurate, if anything, any error occurs, some subsystem error occurs during that installation, that universe immediately deleted. But if everything goes right, it starts to boot on the next reboot of the system. It starts to boot from that parallel universe, not the one you were using. And everything goes right, that becomes your new universe. But if something went wrong, it will reboot back to your previously working state, previously working universe. So that's how it is there. So we call it atomic systems because it is like during runtime there is no change. It has to, and it cannot be a half-baked state. Atomicity is the concept that it cannot be in half-baked state. It has to be fully bad or fully good. If it's fully bad, go to the previous state. If it's fully good, keep on using that state. So that is, and transactional is that while using the system, there is no change. Any application you might install, they're installed in separate layers, not in the OS itself. So that again adds security and all this. Okay, finally, we're coming to the end. I have told you a lot. So we are supporting Windows apps as well, something called TruBridge. A lot of business applications run. Nowadays I play games. I've always had the fancy for games, but I couldn't play because of my other passion. With upcoming versions of like truOS, I'm planning some of the games. Steam, you have heard of Steam. Steam works very well, and most of the games are supported. Even Valve has first party support. So, and we are bringing like this TruBridge is unique to truOS. You can run MS Office or Tally or any kind of these applications that you might need in your future directly on TruBridge. And we have our own app store where you can have thousands of applications to download. And I'll try to give a demo, but I have not activated. That might not work. But in our app store, you have majority of the things that you need. These are native applications. They are not TruBridge driven. They're native applications. And finally, while we started long back in 2008, then we launched a brand called SuperX in 2011. And but one of the major difference that we are taking this year, from starting of this year, is that we are making sure that our system is compatible with global standards. The name, I initially thought of some Indian name, then I thought, okay, I should not give an Indian name, I should give a global name. So that's why I made truOS. And this we have completed. The truOS system is based on either direct certification to us as a vendor or as a product, or we have components that are certified by some other vendors. One of them I'd like to mention again, KDE here. Germany Blue Angel certification from German government comes with our PDF reader, Ocular, which is given to the KDE EV. That for like what you call it? It's for Blue Angel is for like energy efficiency. It's an energy efficiency in the how much energy your software is using during runtime. You might think the PDF reading is a simple thing, yeah, but still it's giving you taking CPU cycles, which is consuming real electricity. Blue Angel focuses on making sure that the systems are energy efficient, and they're also compatible with at least 5-year-old devices. And we are certified in India by the Quality Council of India. So they are the grading agencies for this category, and we are also certified by one of the UK-based certification bodies. Okay, finally, thank you. But I would still like to continue with the demo if you would give me some time. And I would like to mention one thing. So we are coming up with a program called NCAP TruChamp. Mani, would like to add on this program? Okay. So we are launching this program for students exclusively, where you will learn mobile application development for Android, iOS, all those platforms, and on how to do that on truOS. And this NCAP stands for No Code Application Platform. You will do using no code technologies. My other startup, Solworks, is into no code, and this particular program is a combination of no code app development and Linux combined. So whatever I've touched, we'll go into details. I would like to hand over to Mani to give more introduction on this particular program.
Yeah, good morning, everyone. So, how's been the session? Good to connect. I think there are a lot of technical things, and that's the world you're going to face. So, we try to keep it as minimal as possible, but we need to ensure that you get the right connects with the technical challenges. That's why the session is well balanced to have. Okay, now quickly I'd like to connect you with NCAP TruChamp. NCAP TruChamp is a low-code application platform and truOS champion. So this is typically helps students to get the basic skills of working in OS using truOS as a platform, and using the same OS, you will be able to build no-code applications, which can be a mobile applications or a web applications or a hybrid applications that can run on all the platforms. Either it's an Android or as a web application or as an iOS application, right? So this is a very exclusive program that we have designed for students, and you can actually enroll by scanning this QR code. And once you get onto this program, there are a lot of goodies that you'll be getting. You'll also get a free copy of truOS distribution for all whoever completes this program, right? And there are a lot of other updates that we are giving on this program. We're also planning to launch a developer community in connection to this. So whoever completes this program will be part of the developer community, where we will be flooding the community with a lot of internships, projects coming from various other sources. And definitely, this is all in support and in contribution with CSI. Whoever takes this program will get a certification approved by CSI Bangalore chapter. So that's also a good benefit for you guys to take it to the next level and get ready for your career aspirations. That's all I would like to share. Happy learning. With this, I'll conclude.
And yeah, and if you if you please take a photograph or the scan the QR to enroll. Okay, that's so finally, that's our contact details. Both Mani and mine are there. If you would like to. Okay, so that's our contact details. if you would like to connect us directly, you can reach me at hello@truebits.io from email, and these are our phone numbers. You can connect with the business number with money and technical number with me. So yeah, and if you happen to somehow visit Assam, please come to our R&D center. Okay, thank you.
Yeah. Thank you so much, sir. And I would like to call CSI, like Shira sir, to address again. After the vote.
Good afternoon, everyone. My name is Sunshine. Will not take much from you all. But then, yes, I'm from CSI, Computer Society of India. So we have the banner there where CSI we were established in the year 1965, and then this is CSI BC, that is the Bangalore chapter of CSI, which was established in 1972, where it is a non-profit professional society that we have, where it is beneficial for the students, the faculty, the IT professionals. We have a couple of programs with us as well. And coming to what we do for the students that we have that is associated with CSI. One is TECHNOBABBLE, that is awareness and learning that we had in our session today, that is TECHNOBABBLE 1.2, where we encourage and give a talk to the students where most of it would be an expertise on a few topics that is beneficial for you all. And the second one is techies. Those are the skill development, where we have hackathons, we have internships, we have faculty development program, and we also have workshops and trainings which come under this banner. And then we have pickups. Pickups is mainly for incubation and entrepreneurship, where we support and encourage the institution to set up and manage entrepreneurship in their premises, also the incubation. And the last one that we have is TechFund. TechFund is mainly on supporting IT to deliver, set up, and manage the IT-driven programs. Right? So I request you all to make use of all these programs, both faculty and students, to make use of all these programs that we have from PSI. And finally, I would like to thank the Founding Institute of Management Sciences for giving us an opportunity to babble in different lessons. And Dr. Vasu and our Hippolyte, Vijay Kumar, and also Sonia for coordinating for and making it possible in different lessons. And I'd like to also thank Mr. Manini sir for sponsoring progress, for organizing this program at and I also want to thank our speaker, Vishwas Pausik, and also Vikas here for us. And I also like to extend thank Mr. Sir, where it has been very easy for me to coordinate and get this program hosted in your college. So thank you, sir. And thank you.
Hello. One last thing, if you are interested to join the KD community, because that is something you should do as students. Get a lot of opportunities to meet developers from around the globe. And please check this page. Just search get involved ADE. You will come to this page and you have all the documentation here. we're a wonderful community, and we like whatever we are developing. If you are interested to look for truOS and also KD application ecosystem, my laptop is over here. You are welcome to try.
As we wrap up today's session, I want to extend a heartfelt thanks to Rishiraj Kaushik sir and all the guests present here. Rishiraj sir, we greatly appreciate your sharing valuable time and insights with us. Your work on SuperX and truOS has been truly inspiring, and your expertise has made today's event exceptional. Thank you for your contribution and for being with us today. I would like to thank CSI for giving this opportunity. I request Vijay Sir, HOD, Department of Computer Science, to hand over token of appreciation to our guests.